All right, we're going to do examples 9.2, which is common and natural logs and properties of logs. Um, First, we want to go ahead and define what a common log is. A common logarithm is a logarithm with base 10. This is actually what's on your calculator. When you calculate a log on your calculator, it's a base 10. So if you were to write this, you would just put log x, and then that little base is missing because that's an understood imaginary 10. Okay, so a common log is one that has an understood base 10, and that's what you have whenever no other base is written there. Okay, a natural logarithm is a logarithm with base e. And so this would be, this is used most commonly, it's natural, it's used a lot in nature. If you were talking about, remember when we have e, we're talking about continuously compounding. So if you say you had cells and they were continuously growing or continuously replicating, whatever, yeah, then you're dealing with base E. So say you were trying to find, and this might even happen with the swine flu. If we were talking about when is this going to have that 80,000 people if it was replicating at that natural state, base E. This is ln. This is an L, not an I. So it's ln x. And like the one up above it, this is an understood imaginary, that's a understood E. And remember, we know E is the number 2.718. Okay, you could write this, and I've seen people do this. ln is natural log, so that's an L and an N. But you could write this as log base E of x. Those two mean the same thing. They are equal. Okay, so let's write these next logarithms in exponential form. Evaluate if possible. Log 100. So what is that saying? Okay, 10, since it's an understood 10 here, 10 to what power is 100? So y is 2. Okay, next, log 1. 10 to what power is 1? And so it's 0. Good. And since your calculator is log base 10, you could actually put that in your calculator. You could type into your calculator log 100 and it would give you 2. How about this? This is saying 10 to what power is 1 over 1,000. And so what's this 1 over 1,000 equivalent to? Okay, so that's saying 10 to the y equals 10 to the negative 3. So y is negative 3. All right, now look at these next ones. Those are natural logs. What is letter D saying? E to the what power is 1? 0. Why is that base E? Because it's natural log. Because any base to the 1 power is 0. I think you asked me that earlier. Remember, like if you have e to the 1 divided by e to the 1, that's like e to the 1 minus 1, which is e to the 0, and anything divided by itself is 1. Okay. So here, this is e to the what power equals e to the 3/4. So y is 3/4. Okay. And the last one, e to what power? E to x, so y equals x. Okay, good. All right. Very good. So now we're going to define some properties of logarithms. Now these might seem a little abstract. The rest of this section, you're learning some skills. And these skills are going to help you with 9.3 and 9.4 that are upcoming. But for now, you just got to kind of work with me and remember these skills, remember where these things go. And we're just going to practice some basic skills before we get into the applications of them in 9.3 and 9.4. Okay, so let's do these properties of logs. Okay, so our properties, our logarithm of a product would occur with this type thing. Log base b of m times n. And so that equals log base b of m plus log base b of n. Okay, now I haven't actually gone through the proof of this, but I kind of remember this way. You know how, like, whenever you do regular exponents and say you have x squared times x to the 7th, what does that equal? X to the 9th. So it's kind of that same idea, how when these are multiplying, our exponents are adding. So that's the way I kind of make that connection there. No, they're not actually exponents. M and M are answers that you get to an exponential problem. So I don't actually have the proof and the connection between these two things, but that's kind of how I understand that to be similar. Okay, so then what would the logarithm of a quotient be like? That would be like saying log base b of m divided by n. So what do you think those are going to do? Yes, those are going to subtract. So that would be log base b of m minus log base b of n. And I kind of equate that to this type thing. You know, when we had log to the or x to the 7th divided by x squared, what happened? What did we do with those exponents? Okay, and do you know what? I actually just made this connection. This is the exponent for that one, and this is the exponent for that one, and what are these exponents doing? Those are subtracting. This is log base b of m is the exponent for this one. Log base b of n is the exponent for this one, and then what do our exponents do? They add. So that is how those are connected. Okay. But what answer do you get from this? An exponent. And what answer do you get from this? An exponent. And so these are the exponents that are adding together. So that's how that does that. Okay. All right. Now, this last one, we're not going to practice it much in this lesson, but it is super important. It is probably the most important one that's going to help us in 9.4 to solve logs. And it's this one. Log base b of m to the power of p. Do you remember how powers of powers multiply? Well, that's this. This p is a power. And power of a power multiplies. So I take this p and I multiply it by log base b of m. Here's why. And I love it whenever I finally figure these things out. It finally is making sense after talking through this. Look at this. What is this right here? That's actually an exponent. The result of that is an exponent. And so a power of a power multiplies. Well, that's like this. X squared cubed is the same thing as x to the 6th because the power of a power multiplies. So that's what's happening here. This p comes down and it's multiplying the result of our log base b of m. Okay, now use these properties to condense logarithms. That's what we're about to do. So turn the page, and why should we condense logarithms? Why do you think condensing would help us? Good. It makes the problem shorter. Good. It's going to simplify so that we can solve. Okay? So we're going to practice condensing logs, and then we're going to practice expanding logs. And once again, let me say this one more time. This is going to seem a little like, I don't know, ridiculous. Why are we doing this? But these are precursor skills to what you're going to do in 9.3 and 9.4. So here we go. Now, these actually could solve separately, but we're going to pretend that that's not the case, and so that we can practice solving this with the product. If they are adding, then what are they really doing? Okay. So this is 8 times 2. And so I have log base 2 of 16. So what is that really saying? 2 to what power equals 16? And so what is the answer? 4. Now, granted, you could have actually figured that out here because this is 3 and this is 1, and so that makes 4. But we're practicing our skills right now. We're practicing our rules. Okay, these are common logs. So what are their bases? Understood base 10. So log base 10 of what do I do with this 100 and this 10? Okay, 100 times 10. So I have log base 10 of 1,000. So that's saying 10 to what power is 1,000? And what is it? Okay. All right, now how about this last one here? I have log base 2 of 8 and log 10 of 10. They have unlike bases. This has a base 2 and this has a base 10. So you cannot use properties of logs on this part C. Now they do happen to solve individually. This ends up being 3 and this ends up being 1, and so you could actually solve it, but you cannot use the properties of logs to condense them together. Okay. Next is the logarithm of a quotient. What are these quotients going to do? Okay. Log base 2 of 8 divided by 2. So that's log base 2 of 4. So what's that saying? 2 to what power equals 4? Okay. The next one is common log. So it has an understood base 10. Okay. So log of 100 divided by 10. 10 to what power equals 10? Okay. All right, and what do you notice about our bases on these? They are unlike, therefore you cannot condense. You cannot use the properties of logs on that part C. All right. Now, I put these in example 4 to practice the power property, but it actually makes it more difficult. It's just kind of silly. So let's just solve these outright the way we know how. We would solve this by saying 2 to what power equals 8, and so y was 3. So I didn't put some very good examples in there. 10 to what power is 100? And what about this one? Can you do 2 steps at one? 2 to what power equals what? 16. Because it's 32 divided by 2. Kind of did that in my head. And so y is 4. Okay. Now we're going to do probably the most unnatural part of this, but like I said, this is precursor skills to 9.3 and 9.4, so just bear with me. Here we go. Write the following logarithms as a single logarithm. Okay. Tell me about this 1/3. Remember, according to that property about the powers, this 1/3 is actually the exponent to the x. Good. So it's log b x to the 1/3 plus, I'm just going to do one step at a time. What's this 2? It's the exponent to the w. So it's log base b of w squared. Okay, and so then without me showing you, what's the last one going to be? Base b of z cubed. Okay, good. Now, so that was the first step, but we have not condensed it into a single logarithm yet. When these are adding, what are those? They're going to multiply. So what I'm going to have as my final answer is this. Log base b, and then my x to the third is going to multiply w squared. And what's going to happen with the z cubed? Why is it dividing? Because it's minus. And I would put that in parentheses so that you don't get the base confused with it. Okay, so you just condense that into a single logarithm. Okay, so that's the answer that I want, yes. So that is considered a condensed logarithm. And like I said, it's quite abstract right now. But these are precursor skills. You are manipulating things so that you understand these skills in 9.3 and 9.4. Okay, so how would we do this next one? This 2/5 is the exponent. 5 is the exponent. So a condensed log would be what? X to the 2/5 divided by, oops, look, that was supposed to be a y there. Y to the 5th. Okay? Questions there? Okay. We are, no. These are skills. The question is, are we going to graph any of these? And we are not going to graph anything like that. This is precursor skills to solving logs algebraically, not by graphing. Okay. So let's do the last thing and let's go the opposite way. You get one big old funky log and you have to expand it. Okay. So we got one big funky log right here and let's expand it. So let's first separate it into adding and subtracting. So log base b of x to the 4th. And then what? See, how many terms am I going to have? I'm going to have 1, 2, 3 terms. So I'm going to do log base b of x to the 4th. Then what? Plus log base b of y cubed. Good. Log base b of z squared. Okay. Not finished yet because I got those guys right there to continue simplifying by the power property. And so how do I simplify with that power property? Good. Bring it down. So your final answer is 4 log b of x plus 3 log b of y minus 2 log b of z. That's your final expanded version. Okay. Now, the most common error on this next one is that we want to put the 3 and the x to the 5th together. But that 3 and x to the 5th are two separate items. So let's first begin by talking about how many terms we are going to have. One term for the 3, one term for the x to the 5th, one term for the y to the 1/3, and look at how I called that. I just went ahead and called it y to the 1/3. and one term for the x to the fourth. So I have 4 separate terms on this one. Okay, so here we go. Log base 5 of 3. Now what? Plus log base 3 of x to the 5th. Oh, shoot, I did that wrong. Log base 5 of x to the 5th. Okay. Yep, and then in the next step, I'm going to do that. I mean, you might already be at this point where you can kind of start doing 2 steps at once, but I'm still doing 1 step at a time so we don't get confused. Plus log base 5 of y to the 1/3. And the last one is going to be what? Minus log base 5 of z to the 4th. So my last step would take, oh, see, this is a little 1, so that guy doesn't have anything really that comes down. My last step is to use the power property and take down these powers. So this stays log base 5 of 3 plus 5 log base 5 of x plus, good, 1/3 log base 5 of y. Good, 4 log base 5 of z. Done. Okay, so once again, while those skills seem abstract, they are skills to practice so that we can do our next step of solving logs. Okay? All right.